So question 7, in this given expression calculated as indicated, express your answer as a single polynomial in standard form. So now let's calculate again. We have this binomial times this trinomial. So again, we're multiplying these two things together. Now, similarly, I could have this 12 times this 15. I could change 12 to a 10 plus 2, and I could change a 15 to a 10 plus 5. And what I could do is organize it where the 10 and the 2 is one edge, and the 10 and the 5 is the other edge. And what this boils down to is the distributive property twice. What I can do is multiply 10 times 10. 10 times 10 is going to give me this 100. 10 times 5 is going to give me this 50. Then I multiply this 2 through. 2 times 10 is 20. 2 times 5 is 10. And then I'd have 150, 170, 180 would be the answer to that. So I could do that problem algebraically, if you will, by using a box. We also could use distributive property by multiplying the 10 to both pieces and then turn around and bring in the 2 through both pieces. So let's say 10 times 10 would give me 100. 10 times 5 would be 50. And then 2 times 10 would be 20. And 2 times 5 would be 10. So we'd have 170 plus 10, which would end up being 180 as well. So when it comes to multiplying x plus 2 times the x squared plus 4x minus 6, one way of doing it is you could use the box strategy. So if I draw myself a little bit bigger box, notice that the binomial can be on the left side, x and a 2, and the trinomial can be on the top side, x squared, positive 4x, and negative 6. So then I could partition it off. And then if I multiply through there, notice that x times x squared means there's 3 x's present, x cubed. X times 4x would be just 4x squared. X times negative 6 would be negative 6x. So I bring that x to all three pieces, and then I bring the 2 through all three pieces. 2 times x squared would be 2x squared. 2 times 4x would be 8x. And then 2 times negative 6 would be negative 12. Notice that we do have some like terms going on here. So if you notice, the 2x squared and the 4x squared are like terms, and also the 8x and negative 6x are like terms. So if you do the box method, the like terms are going to be diagonal. Now, since it says standard form, I have to do the highest degree first, which is going to be the x cubed. And then the 4x squared and the 2x squared together gives me a 6x squared. That would be my second term. And then the 8x minus the 6x would give me a positive 2x. And then the negative 12 is just dropped in on the end, and that would be your answer. Now, you could also just come over here and multiply this x through all three pieces. So if I do that, x times x squared would be x cubed. X times 4x is 4x squared. X times negative 6 is negative 6x. And then you could turn around and multiply the 2 through all three pieces. So the 2 would go through these three pieces. So you'd have 2 times x squared would be 2x squared. Notice I'm going to line up my like terms. 2 times 4x is going to be a positive 8x, so I'll line up my like terms. And 2 times negative 6 would be a negative 12. So then I'll just use my little bar here to say bring it all down. So this is a sum bar. X cubed would come down. 6x squared would come down. 2x would come down. And then the minus 12 would come down. So I could do it either way to get that result.